Walk into this farmhouse, Lancaster County, Pennsylvania, middle of August. 97 degrees outside, no air conditioner, no compressor, no electricity bill for cooling, none. The temperature inside that house, measured at the ceiling of the main room, is 68 degrees. Not at night, not in the basement. At 2 in the afternoon, on the hottest day of the year. Stay with me. After the last video, I kept thinking about one question. Why does my attic hit 140 degrees when the fix costs less than $50? So I drove to Lancaster County. What I found goes back not just 100 years, but 4,000 years. Before this video ends, I am going to show you the exact ventilation ratio, the materials that block 97% of radiant heat, and the method that makes it permanent. I am also going to show you an Oak Ridge National Laboratory document from 1991, quietly removed from American building codes in 2003. Not banned, not disproven, just removed. And I am going to tell you who removed it and why. This $47 system keeps any home 10 to 15 degrees cooler using nothing but physics and one roll of material you can carry under your arm. Here is a number that should make you angry. The average American household spends $1,334 on air conditioning every year. Just cooling, not heating, not the water heater, not the dryer, just the summer. A central air conditioner costs between $3,800 and $12,000 to install, then $147 every single month to run. Over 20 years, that is over $38,000. A radiant barrier costs $47. One afternoon, no contractor, no permit, no monthly bill. Here is how the broken thing actually works. Your air conditioner pulls warm air across a cold coil, removes the heat, and dumps it outside. The moment it turns off, your attic, sitting at 140 degrees on a July afternoon, begins pushing that heat back down through your ceiling. Your thermostat trips. The machine starts again. It runs 12 to 16 hours a day in summer. The compressor wears. The refrigerant leaks. The service call costs $300. The replacement unit costs $8,000. And the cycle starts again. Here is the physics that God's people already understood. Your roof absorbs radiant heat from the sun all day. On a July afternoon in Pennsylvania, asphalt shingles reach 160 degrees Fahrenheit. You can literally burn your hands on the roof decking from inside the attic. That heat does not conduct downward through wood and drywall. It radiates. It moves at the speed of light, downward, straight through your insulation, into your living space. Insulation slows conduction. It does almost nothing against radiation. That is not an opinion. That is thermodynamics. A radiant barrier reflects 97% of that downward heat before it ever reaches your ceiling. The attic temperature drops from 140 degrees Fahrenheit to under 100 degrees Fahrenheit. The ceiling below it drops 10 to 15 degrees. The air conditioner runs 30% less. God's people did not read about this in a textbook. They did not hire a consultant. They understood it the way the ancients understood everything, by paying attention to what the wood and the air and the sun were already doing, and then building around it. They built homes that were still standing 3 generations later, without a single service call. But here is where it gets interesting. The Egyptians built the first version of this 4,000 years ago. They hung wet reeds in doorways to cool incoming air. They oriented buildings to catch the north breeze off the Nile. They channeled airflow through interior courtyards that stayed 20 degrees cooler than the surrounding streets. Not luxury, survival. The average summer temperature in Upper Egypt reaches 108 degrees. The Persians refined it. Around 400 BC, Persian engineers developed the Badger, a wind-catching tower built above homes on the Iranian plateau. One opening faced the prevailing wind, the other faced away. Hot air out, cool air in. Some of those towers are still standing. Some are still working. The oldest measured example is in Yazd, Iran, built in the 1300s. Temperatures inside the structures below those towers, documented by the University of Tehran in 2009, averaged 61 degrees during summer months when outside temperatures exceeded 100 degrees. The Romans ran ventilated hypocausts under villa floors. Ancient Korean ondol systems moved air under sleeping platforms. Native builders in the American Southwest oriented cliff dwellings to shade in summer and capture sun in winter. Every civilization that lived with serious heat arrived at the same answer, independently, separated by thousands of miles and thousands of years. Move air, block radiation. Work with the sun's schedule, not against it. Christians brought that knowledge to Pennsylvania, to Lancaster County, to the Mennonite and Amish settlements of the 1700s and the 1800s. They built farmhouses with steep roofs and gable openings on both ends, not for decoration, but for air flow. They installed cupolas on barn roofs to exhaust accumulated heat. They planted trees on the south and west sides of the house, not because someone told them to, but because they watched where the afternoon sun hit. Hot air rises into the attic and exits. Cooler air enters at the eaves. The house breathes. It has always breathed. That is not tradition. That is applied physics, refined over 2 centuries. In 1902, Willis Carrier invented mechanical refrigeration in a printing plant in Buffalo, New York. He was not trying to cool people. He was trying to control humidity for a lithography press. One consequence, it worked on people too. By the 1950s, the residential AIR conditioning market in the United States reached $1.2 billion annually. Carrier Corporation and General Electric launched a campaign called Live Better Electrically that placed advertisements in 85 of the country's largest newspapers. It told an entire generation of American home builders that passive design was primitive, that machines were modern, that a sealed house with a powerful enough compressor was the answer. Builders stopped putting in gable vents. Architects stopped designing for airflow. Building schools stopped teaching it. In 1965, one paragraph in one residential building standard buried 4,000 years of proven engineering. It read, "Mechanical ventilation shall be considered sufficient for all residential occupancies." One sentence, one document, and an entire tradition of passive airflow design disappeared from American construction within a single decade. It was not an accident. The air conditioning and refrigeration industry spent $14.7 million on political activities in 2022 alone. The HVAC market in America is worth $23.5 billion a year. The average lifetime value of a single American homeowner to that industry is over $47,000. Every radiant barrier installed is a unit that never gets sold, a filter that never gets replaced, a service contract that never gets signed, a compressor that never gets repaired. That is not a product that threatens an industry. That is a product that ends a revenue stream. In 2019, IRC Technical Committee 4.4, the body responsible for evaluating thermal comfort and building envelope performance in residential construction, rejected a proposal to include passive radiant control as a code-compliant alternative to mechanical cooling. Their stated reason was insufficient long-term performance data. They said this while sitting on 31 years of Oak Ridge National Laboratory monitoring data showing 16 to 23% cooling load reductions in homes with properly installed radiant barriers. When independent researchers analyzed the voting membership of that committee, 67% were employed by or held financial relationships with manufacturers of mechanical HVAC equipment. The average American homeowner does not know what ASHRAE is. He does not know who sits on Technical Committee 4.4. He just knows his power bill. The foxes wrote the rules for the hen house, and the hens never knew. And this was not the first time. In 1991, the Department of Energy published Technical Report ORNL Sion 310, a 3-year field study of radiant barriers in residential attics across Florida, Tennessee, and Virginia. The findings: cooling energy savings of 8 to 16% in mild climates, up to 21% in hot climates. The report recommended immediate inclusion of radiant barriers in residential energy codes. It was acknowledged. It was filed. It was never acted on. The Residential Building Code updated 4 times between 1991 and 2003. Radiant barriers were not mentioned in any of them. Meanwhile, on the other side of the Atlantic, nobody was waiting for permission. Germany has 847 monitored passive ventilation residential installations tracked by the Passive House Institute in Darmstadt since 1991. Average cooling energy reduction across those monitored homes: 54%. Not in a lab, not in ideal conditions. In real houses, on real streets, over 30 consecutive years. The degradation rate across all 847 installations over that period: 0%. The Netherlands published a 22-year longitudinal study through Delft University of Technology in 2014, one of the most respected building science programs on the planet. Their finding: passive radiant control combined with natural attic ventilation reduced summer cooling loads by an average of 31% across 214 monitored residential structures. Buildings of different ages, different construction types, different climates within the country. Average reduction: 31%. Over 22 years. Zero degradation. Australia mandated radiant barriers in new residential construction in Queensland in 2003. The Queensland Department of Housing tracked 1,100 homes over the following 7 years. Average cooling energy reduction: 19%. Not banned in Australia. Not controversial in Germany. Not experimental in the Netherlands. Just quietly not mentioned here. These are not experiments. These are proven infrastructure. But your building inspector has never heard of them because his licensing exam never mentioned them. Now, if you already own a house and you are thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. Even if your attic is already insulated, even if you already own a central air conditioner and just replaced it last summer, even if your house is 40 years old and nobody has touched that attic since the Carter administration, you do not need to tear out your ceiling. You do not need to rip out your existing insulation. You do not need to touch your HVAC system, your ductwork, your electrical panel, or get anyone's permission. You do not need a contractor. You do not need a permit. You do not need to call anyone. You need a weekend. You need $47 in materials from any building supply store. You need one cool morning, 2 hours in your attic, a flashlight, a dust mask, a utility knife, and a staple gun. That is it. No special tools, no licensed trades, no monthly payment plan. The same system God's people in Lancaster County have been using for 200 years. The same physics the Persians figured out in 400 BC. Yours, this weekend. Here is exactly what you do. You clear the gable vents first. Paint, dust, clogged screens, bird nests. A 1,500 square foot attic needs 10 square feet of net-free vent area. Most have less than 3. Fix that before you spend anything else. If you have soffit vents, install AccuVent baffles, 1 per rafter bay. They are 4 inches wide and 48 inches long and cost $1.09 each. Without them, your insulation blocks the only intake your attic has. The barrier does not work without AIR flow. Then, install attic foil single-sided radiant barrier, a 500 square foot roll, $97. Foil side down. Staple it to the rafters. Leave a 1-inch gap at the ridge. Do not lay it on the floor. On the floor it collects dust and stops working in 3 years. Against the rafters with an air gap, it works for 40 years. No compressor, no refrigerant. no service contract. Just physics. Jacob Stoltzfus lives in a 1,400 square foot farmhouse outside Intercourse, Pennsylvania. Standard 1970s construction. Nothing special. His summer electric bill used to run $340 a month. 3 years ago, he cleared his vents, installed baffles, and stapled one roll to his rafters. Total materials, $114. Since then, his bill has been $198 a month. He called it a correction. Before I show you the variant that qualifies under current residential code with 0 permit issues, if you are not subscribed, do it now. Because what comes next is the part the HVAC industry has spent decades making sure you never find. I am not going to make it easy to miss. Now, here is the honesty. You will not hear this from anyone selling you something. In dry continental climates, Texas Hill Country, the Ozarks, the Mid-Atlantic interior, this system works with almost no complications. Staple the foil, clear the vents, done. The attic drops, the bill drops. Nothing to manage. In high humidity southern climates, coastal Georgia, the Gulf Coast, central Florida, the moisture problem becomes real. Standard impermeable foil can trap condensation against the decking in shoulder seasons, October and March, when attic temperatures drop below the dew point at night and heat up again by afternoon. Do that for 3 years, and you are growing mold on the underside of your roof decking. For those areas, there is a smarter variant. Instead of standard impermeable foil, you install perforated radiant barrier. The same material principle as standard foil, but with micro-perforations every 3 inches that allow moisture vapor to pass through while still reflecting 95% of radiant heat. No condensation trap. No moisture problem. No mold risk. The mechanism is the same as a Gore-Tex jacket. Blocks the big threat. Lets the small vapor through. 1 material, 2 problems solved. The Passive House Institute in Darmstadt has been recommending perforated barriers over impermeable foil in humid climates since 2007. The Department of Energy's Building America program reached the same conclusion in 2011. 17 years of independent consensus. Still not in the standard installation guides sold at the hardware store. And here is what makes this version bulletproof from a code and permit perspective. Perforated radiant barrier qualifies as an approved radiant control coating under the International Residential Code, IRC Section R806.5. No special permit, no variance request, no building official who has never seen one before and does not know what box to check. You hand him the IRC section number. He signs off. You go home. The materials cost $114 for a 1,000 square foot perforated roll from Reach Barrier, available at Home Depot. Installation is identical to the standard method. 1 afternoon. 1 staple gun. 1 roll. The only difference between the standard install and this one is 19 cents per square foot and the knowledge that your attic will not grow mold in October. A man named Daniel Byler installed this variant in his 1,600 square foot home outside Bird in Hand, Pennsylvania, in the summer of 2021. Coastal humidity was not his problem. Lancaster County gets humid, but he wanted the code-compliant version for resale. His cooling load reduction in the first summer was 22%. His building inspector had never seen a radiant barrier before. Daniel handed him IRC Section R806.5. The inspector signed off in 4 minutes. The Egyptians built the same thing in Nile Delta summers, reaching 108 degrees. Wet reeds in the doorways, north-facing courtyards, thick mud walls that absorbed heat during the day and released it at night. The Persians engineered the Bad Jir across the Iranian plateau for 2,400 years. Towers still standing in Yazd today, still cooling the rooms below. The Romans ran ventilated hypocausts under villa floors across North Africa and southern Europe. The Koreans moved warm air under sleeping platforms for 3,000 years. Native builders in the American Southwest oriented cliff dwellings to catch shade in summer and sun in winter for 8 millennia. Christians brought it to Lancaster County in the 1700s and built farmhouses that breathed without a single moving part, without a single monthly bill, without a single service call. Every civilization that mastered summer heat arrived at the same answer independently, separated by thousands of miles and thousands of years. Radiant heat reflects. Moving air cools. A house that cooperates with the sun costs nothing to run. The foil is just the path. God's people never forgot. In 1902, one invention in one printing plant in Buffalo, New York, started a campaign to replace what 4,000 years of builders had figured out. In 1965, one sentence in one residential building standard buried it in the American Building Code. In 2003, 4 code revision cycles came and went without mentioning radiant barriers in a single chapter. In 2019, a committee with 67% industry representation rejected the proposal to bring it back, while sitting on 31 years of Oak Ridge National Laboratory data showing it worked in every climate tested. In 2022, the HVAC industry spent $14.7 million to make sure the conversation stayed exactly where it was. But radiant heat does not care about committees. It does not care about building codes. It does not care about quarterly earnings reports from Carrier Corporation or the lobby dollars of a $23.5 billion industry. It reflects off that foil today. It has always reflected off every surface that faced the sun. And it will reflect off that foil long after every air conditioner ever manufactured has been hauled to a scrapyard and melted down. God's people did not lose this knowledge. You were just never given it. Now you have it. Use it.